Hi, in this video I'm going to demonstrate how to solve the problem of a button not working properly. Say it's for a remote or a press button for a door or a limit switch or even a selector switch or even a variable knob like this for a volume control. What happens is over time a little bit of dirt gets between the contacts and in some cases it even corrodes. So if we take this limit switch for example, there you can see I've got a switch. It's supposed to short out that terminal to either that terminal or that terminal. Notice the leaf spring there moving between the two terminals. Now if you look closely you'll see there are these pads, and what happens is as the switch is operated over time some corrosion forms there or even some carbon. If you stay near the coast where there's quite a lot of oxidation, we'll find that this might even rust and it builds up a contact resistance. Therefore when I measure between the terminals, the resistance gets higher and higher and higher, and sometimes it's too high, and that means your circuit or your remote or your press button does not work properly. So how do we solve this problem? Well, there are many ways to solve it, so I'm just going to give you some tips, and I will do a practical example of a switch that has got this problem. So I'm just going to quickly talk you through some of the solutions. The first one is to clean the contacts. If you look closely, if I pull out one of these terminals, there is the terminal, and just over there there's a bump, and that is the contact. Now in this case it looks like it's in very good condition, but you'll find that over time it builds up carbon there, and the best way to solve that is to just take some sandpaper. It can be 200 grit or 400 grit, just to gently remove any of that carbon away. That will solve the problem because you are now making the surface fresh and it will now have good conductivity. The thing is you'll have to do it on both surfaces. So there's a surface there and then there's a surface here. Now in this case I was able to get right into the contact and I could clean it. But what happens if you can't get inside here? Well, take this remote control for example. I'm just going to open it quickly, and on the inside there's a little button. Now these buttons also have contacts inside. Now I can't open this up and clean the contacts, so what I need to do is spray something in here to clean inside there, or to at least try and break down some of the corrosion. Now if you don't have any special contact cleaners, you can use white spirit vinegar, but just be careful because you don't want to wet everything here and cause a short circuit. So you only need to put a tiny bit in there, like a drop. Now you do also get dedicated sprays that do this particular job, and they are very useful. So all I do is I remove the battery, so there is no chance of any short circuits here, and I just make a tiny spray. It does come out quite quickly. Look, there it's already quite a lot, and then I press it. This will get inside there and it will start cleaning those contacts. Over the next couple of hours, it will make quite a reduction in the contact resistance. The contact resistance is the resistance between the contacts, those leaf springs or pads that when they touch must have a very low impedance or very low resistance. Just to explain my point, here is a piece of metal which would normally have a very low resistance because it's metal. But notice it is all rusted. And notice it's a complete open circuit even though it's metal. So I'm just going to take some of this vinegar and put it on the surface here. And already we can see, look at that resistance coming down. It's no longer an open circuit. Yes, the resistance is still very high, but look how the vinegar has started to reduce the resistance. Now, if I take the sandpaper and just sand this down a bit, I'm trying to remove some of this rust, we can start to see the metallic surface coming through there. And I can even put some of this contact cleaner on here and let it penetrate there. And just out of interest, look at that. It went from mega ohm to kilo ohm. It's still very high, but I'm just demonstrating what the problem is. So when you spray the cleaner inside here, or if you clean the contacts, what you're doing is you're wiping away the corrosion from that surface, and then your buttons will work correctly. Alright, so here I can test it. You can see the LEDs coming on there and now it is functional. Alright, so as promised, here's a real life example. This is a garage door opener and there is the button, and when I press the button, nothing is happening. It doesn't operate the garage door. So I'm going to just quickly demonstrate how I fix this. So the first thing I need to do is just make sure there's no live wires here. This is a low voltage DC circuit, so I'm pretty safe if I open this up. Right, so there's the inside. Now, unfortunately, the button is there. Because I'm going to be disconnecting these wires, it's just a good idea to take a photo so you remember the color coding for this. In this case, unfortunately, I have to remove each one of these screws to remove the circuit board. There is the circuit board. It's very dusty in here. All right, so there are the two switches. So I'm just spraying inside there. There's the one, there's the other. And then I depress them quite vigorously. So I'm making sure that that contact cleaner is getting inside there. Right, I press the button. And there we can see the garage door is now working perfectly. The button is operating as expected. All right, so I'll just give it a couple of fast presses just to make sure. And now that is good as new. You can use this method on buttons, switches, volume controls that would normally go when you are adjusting the volume, and any application where there are contacts. Thanks for watching, and cheers.